Okay, so here we are again with a couple more quadratic form equations, and let's just work our way through these ones so that we see it in action. This time we've got x to the fourth minus 15x squared minus 16 equals 0. And again, if we model this as a quadratic form equation, we know that it looks kind of familiar, almost as if we had u squared minus 15u minus 16 is equal to 0. And we know how that one work out. We could factor this directly so that we would have u minus 16 and u plus 1, and then we would set each factor equal to 0 and solve. Only in this case, it looks as though u is being replaced with x squared, and consequently u squared would become x to the fourth. And so if we look at our factored form right here and compare it to the original problem, we see that we actually have x squared minus 16 and x squared minus 1 is equal to 0. So we're going to take each of these expressions, each of these factors, and set them to 0. So x squared minus 16 equals 0. Well, actually, that's not too bad to solve because we know what's actually going to happen right here. This is a difference of two squares, and we know that that factors, in this case, is x minus 4 times x plus 4. And setting each factor equal to 0, we get x minus 4 is equal to 0, and x plus 4 is equal to 0, giving us the two solutions, x equals 4 and x equals negative 4. We try the other one, of course. We have x squared minus 1 is equal to 0, and just like in the problem before it, it is also a difference of two squares, where if we take x minus 1 times x plus 1, we would get x squared minus 1. Setting each of the factors equal to 0 reveals that we actually are going to get 4 different solutions to this equation here. That's a plus 1 right there, equals 0. There we go. So x equals 1 is one of those solutions, and x equals negative 1 is another one of those solutions. And so our solution right here overall would be 4 values of negative 4, negative 1, positive 1, and positive 4 as our solution set. Now, quick substitution into the original equation will verify that these are correct. Let's take a look at the next one, though. We've got x minus 5x to the 1/2 plus 6 equals 0. And again, if we recognize the situation, this looks like one of those quadratic forms again, where if I had u squared minus 5u plus 6 equals 0, I could factor this one directly as u minus 2 times u minus 3 in my factorization, and then set each of these values equal to 0. But again, remember in this case we're saying that u is taking the place of x to the 1/2. Again, consequently, if we're looking at how this works out, that would mean that u squared is equal to x, because x to the 1/2 squared is equal to x to the first, which is just itself, x. So when we factor this out, what should we get? Well, if u is replacing x minus 3, is replacing x to the 1/2 here, we can rewrite this as x to the 1/2 minus 2 and x to the 1/2 minus 3 equals 0, and take each of these factors and set them to 0. Now, the last time we did this, we found that only one of these answers works. And so we might be interested to find out whether or not that's the case here. I'm getting ahead of myself. I shouldn't write and talk at the same time. I always run into trouble. X minus 2 equals 0, and x to the 1/2 minus 3 is equal to 0. Okay, so what are we going to do right here? We're going to add 2 to both sides, treating it as the square root means that we square both sides right here and come up with x equals 4. And if we add 3 to both sides, treat x to the 1/2 as the square root of x, we get square root of x equals 3, and squaring both sides reveals x equals 9. Well, we really should check each of these answers, even though it is a quadratic form. Because it involves x to the 1/2, we need to do that. So our check in this case will reveal that if x is equal to 4, that 4 minus 5 times 4 to the 1/2 power plus 6 should equal 0 if we are correct. And is it? Well, 4 minus 5 times 4 to the 1/2 is the square root of 4. That's 2. Plus 6 equals 0. 4 minus 10 plus 6 equals 0. And yeah, sure enough, 4 minus 10 is negative 6 plus 6. That does equal 0. About x equals 9. Now, once more, substituting this in, we should get 9 minus 5 times 9 to the 1/2 power plus 6 should equal 0. If we've done our job correctly right here, this is 9 minus 5 times 3, the square root of 9, plus 6. And yeah, sure enough, again, right, because 9 minus 15 plus 6 does give us negative 6 plus 6, and so that works out as well. So we actually have 2 solutions in this solution set. Both 4 and 9 work. Okay, radical equations in the next video.